This is Formula Lab number 2, Plato resistors. The goal of this Formula Lab was to create a circuit with certain components, including an LED bulb, a motor, and a resistor, to determine the resistance value of the resistor. Our group's goal was to construct a circuit with the LED in parallel with the electric motor, with both functioning at the same time. And our research question revolved around the resistance values of a Plato resistor for a circuit in which the Plato resistor is the only component, compared to when there are other objects and components added in series and parallel. We found the resistance value theoretically calculated from our resistivity calculations of Plato to be around 435. Upon the addition of the other components as the bulb and motor, we found the resistance value to be 691. The calculated resistance values of the Plato resistor in a circuit by itself compared to the complex circuit were not constant. We believe this to be due to human error, but nonetheless, this indicates the addition of parallel and series components to a circuit does have an effect on the resistance of the Plato resistor. Shown here are our resistivity and power calculations, as well as the why for undergoing this Formula Lab. Shown here are experimental assumptions and variables. Our assumptions included that our voltage meter was accurate, and we assumed that the voltage labels on the batteries were accurate. Our variables included a manipulated variable of the presence or absence of other objects in the circuit. The dependent response variable would be the Plato resistance value, and the controlled variables would be the batteries, the motor, and the presence of the Plato resistor.
There were a few things we had to consider when we made our circuit. We had to factor in the resistivity of Plato material. Our motor was current limited, which means that it needs 300 milliamps to spin about. The LED bulbs need between 2 to 3 volts to produce lights, but more than 20 milliamps could potentially burn out the LED bulb. And these are just some equations we used, like the equation for voltage drop and the equation for calculating resistance of a resistor. And these are also some visual models we used for our circuit. On the left is the model of our circuit. We used 3 batteries, and then we had the resistor in series with the LED bulb. And then parallel to both of those, we had the motor. And then we also have a power box showing that there is more current going through the second loop compared to the first loop. And then also all the way on the right, we have our resistor. The beginning of our lab, kind of in the pre-lab, we started by calculating the resistivity of just Plato, the material itself. And we did this by putting it in a circuit by itself and changing certain aspects to calculate this. And what we got was about 1.87 ohms per meters. We knew that motor had to be in parallel with the bulb and that our resistor should be in series with the LED, because while the motor needed a certain minimum amount of current in order to actually spin, the LED bulb had to have less current than that or else it would burn out.
These calculations show the voltage, current, and the measurements for our hot dog resistor, and then the final resistance measurement of about 700 ohms. And then here's just a picture of the circuit. Some variables that affected the resistivity of the Plato include the color, area, the dryness, and using old solder wires. And some causes of uncertainty are the Plato drying, old solder wires, and the length of the cables. Here is the standard error calculation and the standard deviation calculation for the Plato resistivity. We think that our circuit was successful in our goal because the LED bulb produced light and the motor had enough current to spin. We were able to calculate the resistivity of the Plato in the pre-lab and the formal. In conclusion, this is the resistivity value of Plato by itself, and then also the resistivity value of Plato in the parallels and series circuit. And here is the standard deviation for the resistance values. We said that it was determined that the addition of both parallel and series components to a complex circuit changes the resistance of a Plato resistor. We also wanted to note that this experiment could have been skewed just to human error. Thank you for listening.